Hi, this is Math 1340, and this video is over chapter 1.7, which we'll go and look at linear inequalities and then absolute value inequalities. So first, and with regard to inequalities, um, there's a couple principles we have to look at. If A is less than B, and that is true, then A plus C is less than B plus C. So example with that would be 1 is less than 2. 1 less than 2. We add a number, let's say 3 to both sides. So we have 1 plus 3, which is less than 2 plus 3. And when we know that's true, 4 is less than 5. And the difference of how much 4 is less than 5 is the same as 1 is less than 2. And this works even with negative values. Negative 1 less than 0. If we subtract, let's say, negative 1 minus 3, and we subtract here negative 1 minus 3, we'll get negative 4, which is less than, I'm sorry, the other side would be 0 minus 3. Negative 4, which is less than negative 3. And that is true. And then the multiplication principle is if A is less than B, and we are multiplying both sides by a positive value, then A times C is less than B times C. And we can do that if 3 is less than 5, and we multiply both sides by 2, so 3 times 2 is less than 5 times 2, which is true. 6 is less than 10. Okay. However, if we multiply by a negative value, then the inequality sign changes. So if 3 is less than 5, when we multiply by a negative 2, 3 times negative 2 is less than 5 times negative 2. Then we have negative 6 is greater than negative 10. So we have to flip that sign in the middle when we multiply or divide by negative value. Negative 10 is greater than negative 6 is greater than negative 10. All right, so we have to keep that in mind when we solve these linear inequalities. So the idea is still the same. First thing we want to do is move all x values to the left side. And second thing is move all constant values to the right side. It's always just easier to have the x on the left so you can say x is less than or x is greater than trying to read it as 5 is less than x or something like that. So here we'll add 6x to both sides, and we'll subtract 1 from both sides. So we'll end up with 5x is less than 11. So then x is less than 11 over 5. And divide by both sides by 5 to get x by itself. So that's the third step. Multiply or divide. So there is just x on the left side. Then there's a couple notations we can write this. There's 3 actually. First one's set notation. We'll write that with braces. Then x, a vertical line, x less than 11 over 5. That x is x such that x is less than 11 over 5. It kind of tells you what your variable is, and then it writes the region in the second part. The other way of doing this is interval notation. We have here negative infinity. Negative infinity is always a parenthesis up to 11 over 5, and 11 over 5 is not included since it's just a less than sign. So we have another parenthesis. And then graphing. So we have number line. We can mark 11 over 5. And then on the graph, everything less than that be everything to the left, up to 11 over 5. And we'll use a open circle, or you can use a parentheses to indicate that 11 over 5 is not included. All right, so next one, we'll subtract 13x on both sides to get x on the left. And we'll subtract 15 on both sides to get the numbers on the right. So we'll end up with negative 17x greater than or equal to negative 17. Then divide by negative 17, that's going to flip the inequality sign. We'll get 1. We have x is less than or equal to. And then set notation, x such that x is less than or equal to 1. Interval notation, be negative infinity to 1, and this time we'll use a bracket since 1 is included. And then graph notation, everything to the left, up to 1, and then you can use a closed circle or you can use a bracket. The way it works. Next one, negative 5 over 12x greater than or equal to 3 over 8 plus 4 over 3x. 4 over 3 times x. So the first thing we want to do is we want to get rid of our denominators. So we want to multiply by something that it can divide all three. And the best thing to do is multiply by 24. 24 times negative 5 over 12x greater than or equal to 24 times 3/8, which is plus 24 times 4/3 x. And so that 24 is going to divide with all those denominators. So we end up with 2 times negative 5 x greater than or equal to 3 times 3 plus 8 times 4x. And so here we get a negative 10x greater than or equal to 9 plus 32x. Subtract the 32 over 32x over. Then you get a negative 42x greater than or equal to 9. And when you divide by the negative 42, we got to flip the fraction or flip the inequality. So we get x is less than or equal to 9 over negative 42. That reduces down to 3 over negative 14. So we can write this in set notation, x such that x is less than or equal to negative 3 over 14. Right, as interval notation, negative infinity up to negative 3 over 14. That's included, so we'll use a bracket. Line first. The bracket, everything to the left, and including negative 3 over 14. Now we're going to get into a couple other types of inequalities. We use these when we deal with absolute values, so this is one of the main reasons why we're covering it. First one is conjunction. When you have an expression that's in between two inequalities. So in this case, negative 6 is less than 2x plus 8, which is less than or equal to 10. Kind of like dealing with two equations at the same time, or two inequalities at the same time. So anything you do to the middle, you have to do to both sides. So if we subtract 8 from the middle, we'll subtract 8 both sides. So we end up with negative 14 less than 2x less than or equal to 2. and then divide the middle by 2. We're going to divide everything by 2. So divide negative 14 by 2, the 2x by 2, and the 2 by 2. You get negative 7 is less than x, which is less than equal to 1. That's your region, and it's a middle section of a graph. So when we graph this, negative 7, 1, you're graphing the middle section, everything in between. So open circle at negative 7, close circle at 1, and everything in between. So we write this as set notation x such that negative 7 is less than x, which is less than or equal to 1. Or you can write as interval notation, parentheses, negative 7, and 1 bracket, since it's included. Main thing is you do something to the middle, you got to do it to both sides. And the middle tells you what you have to do. You have to do opposite in order to get that x by itself. So the next one we have 5 is less than or equal to 2x plus 6, which is less than 10. Subtract 6 from all sides. You get negative 1 less than or equal to 2x less than 4. And divide everything by 2. We get negative 1/2 is less than or equal to x, which is less than 2. So set notation of x such that negative 1, the negative 1/2 is less than or equal to x less than 2. Interval notation, the negative 1/2 is included. And the 2 is not. And then graphing it, negative 1/2, 2, close circle at negative 1/2, open circle at 2, everything in between. Third one on this page, we have negative 7 is less than or equal to negative 3 minus 2x, less than or equal to negative 1. So first we'll add 3 to all sides. Negative 4 is less than or equal to negative 2x, less than or equal to 2. And then we'll divide by negative 2. Now that's going to flip both inequalities. The automatic feeder on our cat's phone, so you may hear that. All right, so this is going to be 2 is greater than or equal to x, which is greater than or equal to negative 1. That may be a weird way to write it, so we can flip it back and go negative 1 is less than or equal to x, which is less than or equal to 2, which makes more sense to write it this way. So the set notation is x such that negative 1 is less than or equal to x, which is less than or equal to 2. Interval notation, we both are included, so negative 1 to 2, and we use brackets. And the graph, close circles at both, or negative 1 and 2, and everything in between. Right, so that's the conjunction. The disjunction, we have two inequalities that are both solutions, and they're all going to be situations, and we'll see in this chapter situations where this happens. Both regions are solutions, but they're not joined together. So we have to solve each one separate, and then we'll go through the same set notation, interval notation, and graphing it. Right, so we have 2x minus 1 is less than negative 3, and 2x minus 1 is greater than 5. We'll add 1 both sides for both equations. We get 2x is less than -2, 2x greater than 6, and then divide by 2, get x is less than -1, and x is greater than 3. So in set notation, x such that x is less than -1, or x is greater than 3. In interval notation, we do a union symbol with this. So we do -infinity to -1. -1 is not included, so we use a parenthesis. Union with 3, also not included, infinity. And then graphing 1 and 3. Everything less than 1, so it's on the left side, and everything greater than 1, not including that. Everything greater than 3, so it's on the right side. Here we got 3x minus 6 is less than -11, or 3x minus 6 is greater than or equal to 1. So add 6, you get 3x is less than -5, or 3x is greater than or equal to 5. So divide by 3, you get x is less than -5/3, or x is greater than 5/3. So set notation, x such that x is less than -5/3, or x is greater than or equal to 5/3. Interval notation, -infinity, -5/3, union with, and 5/3 is included, 5/3 to infinity. And then we got the graphing. So -5/3 and 5/3. 5/3 is included, and everything to the right of it. -5/3 is not included, but everything to the left is. Last one of these. 5x plus 1 is less than or equal to -14. 5x plus 1 is greater than -6. Subtract 1, you get 5x is less than or equal to 14. Subtract 1 here, you get 5x is greater than -7. 5 by 5, you get x is less than 5, which is 3. X is less than or equal to -3. And on this side, you get x is greater than -7/5. So in set notation, x such that x is less than or equal to -3, or x is greater than -7/5. Interval notation, -infinity, -3, including -3, union with -7/5, which is not included, to infinity. And then graphing -3, -7/5, everything to the right of -7/5, not including that, and everything to the left of -3, including -3. So some applications with this, we're going to look at this first one that deals with interest, simple interest. Joe plans to invest 15,000 part at a 4.5% simple interest and the rest at a 6%. What is the most he can invest at 4.5% and still be guaranteed at least 780 interest per year? So the interest is where your inequality is. That has to be greater than or equal to 780 since it's at least. And so calculate the interest. You take the interest for your first account, which is x is going to be amount invested at the 5% plus the 6% times 15,000 minus X. That is what is being invested. 6% is whatever is left over. And that has to be greater than or equal to 780. So we can solve this by distributing the 0.06. So let's do 0.06 on the calculator. 15,000 times 15,000. We get 900 minus 0.06x, 0.045, greater than or equal to 780. Right. When we put the x's together, we get a negative 0.015x. When we subtract the 900 over, we get a negative 120. And then when we divide by the negative 0.015, we get x is less than or equal. We got to flip that. The 120 over 0.015. Negatives will cancel out, but you still flip the inequality. 120 divided by 0.015 gives 8,000. Okay, so 8,000 must be invested into the 0.045 account is less than or less. So you don't want any more than 8,000, otherwise you end up making less than. The next one is Jessica wants to compare two ways of selling insurance. The first way is Plan A has a salary of $850 per month plus a 10% commission. Plan B has a salary of $1,200 per month plus an 8% commission and sales above 3,000. So we're going to assume that all sales are above 3,000 for one, and then we're going to look at what is better, the Plan A or Plan B. Actually, we're going to look to see when Plan A is better than Plan B. So our start with this. Let X be sales amount, and then we're going to look at Plan A being greater than Plan B. So Plan A is 850 plus 0.1x. That's going to be greater than the 1,200 plus 0.08 times x minus 3,000. This is anything above 3,000 is being at 8% interest. So we will distribute that. So we'll have 850 plus 0.1x greater than 1,200 plus 0.08x minus and 0.08 times 3,000. 240. All right, so we'll subtract over the 0.08, we get 0.02x greater than, and then subtract over the 850, so we get 1,200 minus 850 minus the 240, you get 1. And then divide by the 0.02. You get 55,000. That's the sale amount that would be needed in order to have Plan A be better. Last couple things we're going to look at for this section is absolute inequalities, and actually we've already done a lot of the work on this, so it's just knowing how the inequalities break down. If we have a less than sign, so absolute value of an expression less than a number, then it's going to break down into a conjunction. So negative a less than x less than a. Okay, so in that first one, absolute value of x is less than 8. That means x has to be between 8 and negative 8 and 8 in order for that to be true. In order to take the absolute value and get a positive number that's less than 8, well, your x has to either be a positive number less than 8 or negative number less than negative or greater than negative 8. So once we do that, and if we have an expression other than just an x, we solve for x in the center of that inequality, just like we have been doing. But this is our solution now for it. If it's a less than equal sign, it follows the same rule, just you have a little equal sign there. So again, set notation, negative 8 less than x less than 8. Interval notation, parentheses negative 8 to 8. Then graphing negative 8 to 8. These are open circle, everything in between. So if we have absolute value of x plus 10 is less than or equal to 3, we'll do x plus 10 is less than or equal to 3, and x plus 10 is greater than or equal to negative 3. Do these off to the side. Plus 10 is greater than or equal negative 3, and it can be written as negative 3 is less than or equal to x plus 10, which is less than or equal to 3. So now we subtract 10 on both sides, you get negative 13 is less than or equal to x, which is less than or equal to negative 3. So set notation, negative 13 is less than or equal to x, which is less than or equal to negative 3. Interval notation, these are including both negative 3 and negative 13. And graphing includes both and everything in between. Last one, w is minus 1/3 is less than 3/4. We have negative 3/4 is less than w minus 1/3, which is less than positive 3/4. So we are going to add 1/3 both sides, so negative 3/4 plus 1/3 less than w, which is less than 3/4 plus 1/3. Okay, so let's find a common denominator here. It's going to be negative 9/12 plus 4/12 less than w, which is less than 9/12 plus 4/12. Right, so that'd be negative 13/12 less than w, which is less than 13/12. I'm sorry, negative 5/12. It's less than w, which is less than 13. Okay. So set notation, negative 5/12 less than w, which is less than 13/12. Interval, negative 5/12, 13/12, and you use parentheses for both sides. And the graphing, these are open circles, everything in between. The last one, the greater than sign or greater than equal sign creates a disjunction. And so here we'll have for absolute value of x to be greater than or equal to 4.2, x has to be greater than or equal to 4.2, or x has to be less than or equal to negative 4.2. So, less than would be -5. If x is -5, then absolute value of -5 is 5, which is greater than 4.2. So set notation x such that x is less than or equal to -4.2, or x is greater than or equal to 4.2. Interval -infinity to 4.2, use -4.2, use a bracket, union with 4.2 to infinity, and then graphing. Draw the graph here. Well, -4.2, 4.2. Both are included, close circles. And anything greater than 4.2, anything less than -4. Okay, last one, we'll have x minus 5 over 2 has to be greater than 1, or x minus 5 over 2 has to be less than -1. And multiply by 2, you get x minus 5 is greater than 2, or x minus 5 is less than -2. Add 5, you get x is greater than 7, or x is less than 3. 3, 7. We're graphing it in circles, anything to the right or left of 3, anything to the right of 7. Set notation x such that x is less than 3 or x is greater than 7. An interval notation infinity to 3, union with 7 to infinity. Okay, that is absolute values and linear inequalities, and I'll see you in chapter 2.